Hey everybody, welcome to our series on OpenShift virtualization. We're going to do some demo vignettes that will hopefully guide you through the basic elements of configuring and working with OpenShift virtualization on Fusion in particular. Really happy to be joined by Craig Wilcox from our US SWAT team. Craig is an SME on all things Fusion and OpenShift and has been really leading the charge for a lot of the work we're doing with OSV. Craig, thanks for joining, first of all. And we're going to go through a series, or Craig is going to go through a series of live scenarios. So you're actually going to walk through it and we'll describe what's going on. There's kind of about a half dozen different things we're going to step through, and we'll break this up probably into chapters so you can consume them individually. So Craig, I'm going to go off video and hand it over to you to screen share, and let's go.
All right. Thank you, Randy. So we're looking at the OpenShift console web UI here for a Fusion HCI cluster that we have available for demos. And out of this environment, we want to demo OpenShift virtualization and talk through the use cases of creating virtual machines and managing some of those after they're created. So the first place we'd start is Operator Hub. Operator Hub is where you add functionality into your OpenShift cluster. And we're gonna look at what operators we have installed in this cluster here to talk through what we did before the demo started. So a lot of capabilities that you typically see around Ansible and AMQ and Grafana. Those are very common inside of OpenShift. As we go down, we see that there's some IBM CSI drivers available and the IBM Storage Fusion Backup Restore that can be used for data protection for your enterprise containers, as well as data protection for virtual machines.
That CSI driver is mounting external flash system storage, I believe, right?
Yeah, so the same CSI driver from IBM is used for our flash system products and our DS8000 products, right? And so that makes it possible for this cluster to consume that all-flash array technology that we have inside of the storage brand. And then Backup Restore agents have a small footprint to do the snapshots and the data mover workloads. The server, you can have a single hub that manages multiple OpenShift clusters, and that has the catalog of all of the backups that have happened since the beginning of the enterprise deployment, as well as policies to know when to delete those. So when e-discovery comes a knocking, you've got all of those old backups deleted, and then you have enterprise view of the health of all of those backups too, so that we can make sure that we have some governance wrapped around it instead of each project owner kind of managing Backup Restore themselves. And then Storage Discover is our data cataloging tool to bring policies and visibility around file systems and object storage buckets in a single data warehouse that we provide for you to be able to query against. That's popular with data science workflows. It's also popular with customers that want to have data scanning, looking for PCI or PII data, that sort of thing.
Yeah, and looking at IBM storage, you'll note that the cluster is in the midst of an upgrade, actually. So there's kind of a live upgrade going on to 2.7.2.
That's right. 2.7.2 is very new. It just came out last week. So we're excited to be trying that out here too for the demo. All right. And then OpenShift virtualization is available from Red Hat's container registry. And that's installed as an operator into this cluster that provides the UI and all of the management for the virtual machines. Kind of the equivalent of Virtual Center in the VMware ecosystem, right? Is OpenShift virtualization. And then Migration Toolkit for virtualization. This is an operator also available from Red Hat's container registry that lets you take virtual machines that are either running in a different OpenShift cluster, and I want to do cross-cluster migrations, or heterogeneous migration from a source VMware cluster to migrate virtual machines into OpenShift virtualization for the first time. Okay. Then we have Data Foundation, which is the software-defined storage container ready storage for file, block, and object out of a single pool of capacity built on top of the open source Ceph and Rook projects. And that's pretty much it for the operators that we have. So hopefully some of that was review for you if you've seen some of the OpenShift before. If you're new to OpenShift, that's really kind of how to dynamically update things in the UI, and long-running operations inside your cluster is through the operator framework. Okay. Then from there, once that OpenShift virtualization operator is installed, the virtualization feature will show up here on the left. This specific cluster already has multiple virtual machines installed and running, so that you can see there's 28 virtual machines currently. Across those, they're using 40 vCPUs, a few hundred gigabytes of storage, and 24 or so gigabytes of RAM. We could drill into these to look at trending. If we have this environment running for weeks or months, then you can use that for forecasting across the full cluster, right? And then you can kind of see a little drill down of different types of virtual machines based on the templates that were used. So that's kind of current state. In addition to that, we'll want to create a new virtual machine. So we drilled down specifically into virtual machines in the UI on the left. Here's a list across all of the projects in my environment of the virtual machines that are created. That's those 20 or so virtual machines. For our demo today, we're going to go specifically into the IBM virtual machine namespace that we have on this cluster. And then we'll go to create, and we'll create from a template. Today we'll do Red Hat Enterprise Linux 9. And so that a lot of these sort of list views or tile views inside the UI have these dynamic search filter boxes up at the top. So I put the number 9 in. That gives me CentOS Stream 9, Red Hat Enterprise Linux 9, and Windows Server 2019 as choices. If I click into Enterprise Linux 9, this is a built-in template that comes from Red Hat, so this wasn't one that we custom created. If you want to have your own gold image as a customer that your Enterprise Linux team curates for you, then you can have that as a template that you predefine, then stamp out as many of those as you want through the life of your cluster. By default, this template gives us one virtual CPU with 2 gigs of memory, which is pretty small just because this is a demo environment. It'll give you a default name, and you can override that to be whatever you want. From there, you could just click on create and it'll give you all defaults. We'll dig into customize so you can kind of see what they're doing for defaults here. So they'll give you a 30 gig virtual machine disk for your root boot volume, and because it's not Windows, we don't need the Windows drivers disk. This template has all of the OpenShift virtualization drivers built into the virtual machine. And then the cloud user password is randomly generated. You can override this to be whatever you want. We'll do FusionCast as our cloud user password. And you can see the username will be cloud-user, and then the password will be FusionTest. We'll see that later once the virtual machine's running. And from there, we can see all of the defaults that it's giving us, this 30 gig virtual machine and the memory, the network that we attach to. And from there, we can do create and leave the checkbox to auto start this virtual machine. So here, the status field will automatically dynamically update as it creates the pods for managing the virtual machine. It'll create the virtual disk files. It'll do some cloning to get the template injected into the virtual machine. And from there, it will start it. So you can see through this small console preview, the virtual machine starting. This eviction strategy is part of the policies of the OpenShift cluster. So if a single node in your cluster starts using too much CPU and memory, either because it's getting loaded up with pod workloads or virtual machine workloads, you can use this live migrate capability to move your virtual machine to a less busy node. So it kind of auto balances as the workloads grow up towards a threshold that you set as an administrator. So that's all right. While it's still booting, not able to change that setting. So let's look over at the virtual machine console here. Underneath the VNC console preview, there's this open web console link that'll pop up a new tab. And here we get the login. So I put in the cloud user that's created by the template, and I put in the password that I'd used when I created this. So from here, you can see the IP address is 10.0.22. If I go back from this back to the other browser tab, we can see the network interface integration up here showing on the other side also. So the 1030.3.70 through the OpenShift services network is exposing that IP address out to users that need to connect to the system.
Cool.
Okay. And
so
then
that was a very pretty simple workflow. I mean, without talking through it, it's a minute.
Right. Yeah. And the great thing is, the user interface and the wizards are great for that first virtual machine you create. Under the covers, all of these are getting created with text definition files. And so it's fully API driven to be able to create all of these programmatically also, right? So that's the great thing about OpenShift in general is we have UIs to learn how the tools work. Everything that's created in the UI generates text config files in the back end for driving automation as well. So from there, we can look and see at the blocks LS. Okay, so this shows that we have that 30 gig virtual disk that we defined in the creation template, and it auto partitioned that to put the boot drive and the different spaces as you're used to seeing in enterprise Linux, right? So from there, we want to be able to take a snapshot of this before I get into the virtual machine and start causing too much problems that I can't recover from, right? So from here, we've got the different tabs. Details, again, shows a lot of those settings we had in the creation wizard, where you can see those in the UI. Metrics, this is where you see the CPU utilization. This would populate over time as that's collected into Prometheus inside of our cluster. YAML is the text.
Circling back to that eviction strategy window, the VM has to be down for that to be changed, right?
So the eviction strategy by default has the live migrate already set. So there's not really a change that we need to do. Now that it's up and running, that save button works. It was still kind of in the creation workflow. So, yep. And then, all right. So this is kind of the text version of all of the UI wizard work that we did on the front end, right? So then this can be backed up and used for automation use cases. This shows the disks. We have that 30 gig disk here. The file systems, it can inspect into the virtual machine to see those network interfaces, what the MAC address of my virtual machine is, the networking type that we have. We're using NAT for this particular network to have a private network for demoing. And then the different rules for which nodes in the cluster it can run on. If we have different virtual machines that have affinity or anti-infinity rules for resiliency, if I'm going to do a horizontal HA cluster across two virtual machines, I want them to run on two different nodes in my cluster. That kind of settings can be done here inside of the scheduling part of this too. And then different integrations for custom configs. Okay. And then from there, I mentioned I want to take a snapshot so that if I make changes to this that I want to roll back, I have a clean snapshot to start from. Again, it'll autofill in a random name. You can put a description in to help you remember what was going on when you took the snapshot. By default, it'll include all of the disks. Cloud init disk is static. That's used for the automation for the install, so we don't need to back that up because it'll never change. It's not even a read-write PV. Okay, so now you can see the status is in progress. It automatically updates in the UI as we go through to generate that snapshot, right?
And you can do that, throughout this whole creation workflow, just to have different checkpoints along the way.
Exactly. Or, if it's a critical business app, you maybe want to schedule snapshots also, right? And that can be done right inside of here. The Fusion tool that we talked about in the operator hub, that also has the capability to orchestrate these snapshots so that you have rollback points inside of the cluster. That also has data movers and integration for pushing those snapshots out to object storage buckets. So with OpenShift combined with the Fusion capabilities, you can have kind of the basics interactive snapshotting that we're doing here, but also have all of that centralized backup server kind of experience that customers like to have for seeing the health of all the backups that are happening in the environment, as well as being able to do cross-cluster backup restores, that kind of thing. Okay, so that's the snapshot. If I go back to the environment, the snapshot shows up here in the summary, so we can see that briefly. If we look at the disks, again, we had this cloud init disk that is read-only, but if we wanted to go and make this boot disk larger, we click in here. You can see that it's 30.2 gig. And then up in the right, I click on Actions, and one of the options here is Expand PVC. So that's Persistent Volume Claim, and that's terminology in the OpenShift and Kubernetes world for persistent storage. So here we want to change it to 60. I'll try that again. 60 gigabytes, roughly double the size. And if I do expand, it'll dynamically update here as I requested 60, but it's currently 30, and it'll auto grow that. So then while it's doing that, we can look at the virtual machine again. And that is back in the virtualization view, virtual machines. And if you remember from earlier, I named it Red Hat 9 Fusion Test, and there's another one of those views that gets dynamic filtering support. Okay. You can see while we were coming here, it finished the resize, and the size of the volume is now 60 gig. If we, our console timed out. If we go back to the console and we do the ls block command again, remember from the previous time we were in here, it was 30 gigabytes right here. Now it says 30. We'll double check on that to see if the
screen is cut off a little bit on the left, but yeah, you can.
All right. So I think it's still asynchronously doing that update because I'm not seeing it from inside the virtual machine. So we'll take a quick look at that again. And it's still working on the resizing when we look down at the bottom here. So we'll let that run. And while we're doing that, the next thing that we want to look at is how to do live migration between different nodes in the cluster. So from the virtual machine view for this Fusion virtual machine, we'll look down to the details here, and we can see that we're running on a node in the cluster named compute-0 inside of this cluster. And if you're new to OpenShift, we'll look briefly at the compute here so you can see what that looks like. This system has 3 control plane nodes, and it has 5 compute nodes. And this particular system for our demo is configured so that the control plane nodes can also run work on them. So when we do a migration, it'll either move from the compute node that it's on to another compute node or possibly to the control plane node. So going back to the virtual machine, when we look at the details here, we can see we're on the compute 0. If we go to actions and we do migrate, that kicked off a migration to another node. And now if we go down to details and we look at which node we're running on, it says that it's running on control 1, fusion 0, right? So
it moved
that was
off
very
compute
quick.
to a control node, which normally the control nodes would be isolated from this, but on this cluster, they're fair game for deployment, right?
Yep, and that's a cluster-wide config setting that you can decide. Just like when we were looking in the configuration here at the scheduling tab, we could say which nodes we want to restrict this to. So this one says all 8 nodes in this cluster, including the 3 control plane and the 5 workers, are valid for us to migrate to.
And just worth mentioning here, worth mentioning here that Fusion, with the implementation we have of RWX, enables this live migration to occur, whereas other platforms are not able to support this. So this is a pretty significant differentiator.
Yeah, so for virtual machines to have this support, to not need to take the virtual machine down, copy everything to another PV that can run on a different worker node in your cluster, and then bring it back up. The ability to have all of the storage visible to all of the worker nodes in your cluster and the control plane nodes in this example is the power underneath this live migration, and is also why that migration went so quickly. So all we had to do was stream the dirty pages of memory from one node to the other, and the storage didn't have to move, right? Because both of those nodes were able to access the exact same persistent storage in the cluster.
Yeah, so, cool.
Yeah,
okay,
excellent point. Okay, so that is the migration, and then if we go back here and we check this LS block again, we should have this one updated now. Yep. And that's still pending. So it's possible that it's waiting for the virtual machine to reboot for that workflow to finish.
Yeah, could be.
The next piece is migrating the virtual machine to other clusters. There's a migration toolkit to do that. If we wanted to be able to back up this and restore it to another cluster, we can use that hub and spoke support in Fusion to create a policy to do the backup. We can either do kind of an ad hoc one-off like we did with the snapshot, or we can have a scheduled backup for those production apps that need that. Developers also often want to be able to clone a virtual machine. That's something that you can do. If I've made changes that I want to have in my clone, we can do that quickly here. So I'm currently in the home cloud user. I created a file, my data file.dat, right? So that just so that when I make the clone, you can see the data that's here. And then from the UI, we clone this, and it auto creates a name for the clone. It'll put in the same namespace, and then we'll tell it to start as soon as the clone is done. Very easy again. The wizards here, I've been working with Red Hat for quite a while to make a lot of these UI flows very intuitive and easy to do.
Yeah, very linear workflow, super easy. Yeah,
exactly. And the status of provisioning here, it's giving you information, so it's cloning all of the data, the storage layer. It's also creating the virtual machine definition for the KVM hypervisor under the covers here, so that everything's ready to go as soon as all of that cloning process completes. Because we've got that 30 gigabyte volume, it takes a little bit of time under the covers to copy all the blocks over, get everything set up, and get the pods ready to go. So that dynamically updates here. While that's going, you can see it switch from cloning to provisioning. So that's done with the storage layer and getting the virtual machine definition going. And the next thing it'll do is start the virtual machine. You can see the root disk here is 63 gig to match that resize we did. And then it'll start the virtual machine here next. So this is something that we're seeing a lot of interest from customers around the US and around the world for being able to take advantage of this technology. The integration for Linux and Red Hat Enterprise Linux in particular is deep, as you can see here. All of that pre and post hook works with Ansible, works with all of your existing workflows for satellite, if that's your preferred provisioning technique, right? So a lot of different use cases for creating new VMs, whether you like the VMware-centric cloning and template kind of deployment model, or you prefer the PXE boot and find a satellite server and do a scripted install from my Red Hat server. All those use cases kind of work.
Yep. And we're always careful, not to position OpenShift virtualization as a plug and play, replacement for the most popular platform, the most popular hypervisor in the industry. But on the other hand, it is very functionally rich. It's changing and getting updated and augmented and enhanced all the time. So it's a very powerful, and it's included with OpenShift. So,
right. And we talked about Linux quite a bit in the demos here, but the same hypervisor and all the same UI flows work well with Windows virtual machines. And that Windows Server 2019 you probably saw in kind of the template list, and that's there and kind of code tested and certified with Microsoft, so that you can feel comfortable with both varieties of virtual machines here. Okay. Cool. So then while that clone's completing, let's look at the migration toolkit. So migration was another operator that we had inside of OpenShift, and that operator helps us grab a virtual machine from outside of our cluster somewhere and stream all of its storage contents, its network definitions, and in some cases where live migration supported, the active memory contents into our cluster. Okay, the way that this technology works, which is built in from an entitlement perspective in your base OpenShift license from Red Hat. So this isn't a a la carte separate tool, but how this works is you create a plan for migration. You create connections for different providers. So we'll look at that first. We'll go to looking at the providers that are in the system. So this test environment has a virtual center endpoint that it's connected to. This is the vCenter 2023. And it also has a target of itself. So the target of itself is when you do a migration plan, you do a from and a to. The host one is built in and will be auto-populated for you. So if we want to add another virtual center cluster, we do create provider. And then from here, there's different sources. So I can stream from an OVA file where that makes sense. Instead of a running virtual machine environment, I can stream from a virtual center connection, or as a source, OpenStack, OpenShift virtualization in a second cluster, or Red Hat virtualization. Okay, we don't have other environments to define, so we're going to use the existing one here today. If we click into that one and look at its settings, we have the URL for the vCenter, and in OpenShift, secret is and Kubernetes is kind of the terminology for user ID, password, kind of confidential information.
Credentials.
Yep. And how Kubernetes and OpenShift does that is you get a name that you can then associate with other parts of the environment. So we have a secret in our secrets database with the name of ATG vCenter here that has the user password credentials to talk to this one. Okay. So once those are done, you create a plan, and there's a few existing plans from previous migrations that have been done in this system. The plan name here for our demo today we'll just type in a unique name. For source provider, we're going to pull virtual machines from the VMware cluster. And for target provider, we're going to migrate them to ourself, or the host, which is our, and then the namespace is down here.
I think you've got another live search bar there too, right?
Yeah, I'm trying to remember which namespace we
I think it's that one.
I believe it was the VMs one again. Okay, so then we do next. And there's by clusters or by folders. For the demo, we're going to do the by folders choice here and drill in and select the Fusion VMs. And you can see there's warnings here. The warnings are whether or not they can support live migration. So if we do the twisty, it'll give us more details about what's generating those. So one of the warnings is that there's HA turned on the source cluster, and another warning is that UEFI is set with secure boot,
which RHEL 9 requires, right? So that's one of the things you can't really turn off.
Yeah. So if you're doing RHEL 9, you'll be doing a non-live migration right now. The Red Hat team's working in development on relaxing some of these restrictions over time, because we know that there's a lot of interest in being able to migrate more and more use cases live, right? It just makes it a little easier for change management for our customers. So then
this is also a great feature for even managing multiple environments, like in a pre-production or a DevOps kind of CI/CD world, right? So great way to do that.
Yeah, and if you have workloads in different data centers, you could use this tool to migrate virtual machines from data center A to B, right? All those kinds of use cases can take advantage of this. And as you can see here, it's roughly the same amount of work in terms of UI navigation to do one virtual machine versus all of them in an environment, right? So we'll select all three in here. Then network mapping is what network does it look like in the source environment. So VM network 2, if you're familiar with VMware, you'd recognize that as kind of a default name, VM network 1 and 2 on your source cluster. And that's the same thing. If you logged into the Virtual Center UI, you would see it under that same name. So that's handy. And then you can check from all the different networks defined in this target network. Because this is the test system, there is a lot of networks in the list here, but by default, it would just be the pod network that you would see. And then step to the next part of the wizard. This is where we take the virtual disks and kind of that VMFS on the source side, where we're grabbing our items from, and then the storage class, IBM Spectrum Fusion. And as Randy mentioned earlier, this IBM Spectrum Fusion is a popular choice for the target namespace because it's an RWX technology. And by choosing that as the target storage class, now all of the worker nodes in my cluster are available as targets for this migration.
Although we got to rename it to get rid of Spectrum, but we'll cross that bridge when we come to it.
Fair enough. Yes. Then the migration type, we're going to do a cold migration today. Warm migration, if we met all of those prereqs, would stream the memory contents across and then do a final cutover, similar to that vMotion technology from VMware, right? And because automation is important, in some cases you might have different device drivers on the target system that you're migrating to. So if you're coming from an environment that has its own proprietary device drivers to an environment that needs different device drivers, you can do pre and post hooks to take care of some of those customizations. And again, that's something that you would figure out an operating system type at a time, not per migration, right? And there's different ways to put those hooks in, either running scripts to do that before or after the migration, or
you can even ingest like a local Ansible playbook or something, right?
Exactly. So one of the options is to just pick a file of an Ansible playbook, and you can choose to have it run before or after the migration completes. Or if that makes sense, you can even have a custom container image that you've built that runs once as the container inside of the context of the storage and the virtual machine. Okay. We're not going to do any hooks for this demo today, but you get a nice summary of what your plan is. When you do finish, this plan that we just created gets immediately added into the list of plans. And then based on change management windows for you and your business, you could schedule this to start or just interactively click on start when you're ready for the migration to kick off. Okay. So now that I hit start and confirmed, it's going to look at all three of these VMs, and it's going to step through all of the inventory collection on the source side, looking for all of the disks and the source and target image type if it needs to do a V2V conversion.
The visualization here is really good too. It's really intuitive.
Yep. And by having the dynamic time updated when you drill into the twisty, you can make sure that everything's moving along.
Yeah.
And
very cool.
This is really, kind of speed of light and network bandwidth is really going to define how long this takes. Like,
sure.
The further apart your source and target are, the longer this will take. But there's really no hard limits. We've got customers and demos that have kind of streamed these across the globe, and that works fine as long as you have enough patience for the data to get from A to B. Right?
Well, start it and go to lunch. Nothing wrong with that.
Exactly. And so then you can see the live status here. If we were to go back to looking at the other virtual machines and navigating there, all of this is still asynchronously sitting here ready for us to drill back in and look at the progress. Right. So all of that is available through the UI here, and under the covers through the magic of Kubernetes, it's going to just keep chugging away on this process till it's done. Very Even cool. If nodes reboot in the middle of this happening, it keeps track of the state of everything that's going on. And again, just reiterate, we're obviously kind of talking through this for demo purposes and explaining, the workflow, but it's actually very simple. I mean, if we were just sitting down to go through these scenarios of these vignettes, I mean, it's probably 10 minutes in total, right? So it's a really efficient environment. Very much so. Yeah. And you're not redefining networking every time you do a migration. It's right. Some of these tasks are something you do once per cluster, not once per virtual machine, right? So cool. It really does scale to pretty good productivity as we go. Yeah.
Well, I think that kind of brings us to the end of the workflow for this series of demos. This was awesome. Mm-hmm. It was really cool to see the workflow, see how easy and intuitive it is, and also to get a better sense for the value of running this on Fusion and what it brings to that migration workflow is pretty cool. So, Craig, awesome as always. Thank you so much for your time and for jumping into the live demo environment, working without a net. So we appreciate that. Thanks everybody for watching these demos. We'll get these produced and delivered. I think there are going to be more of these in the future as we add more capabilities, more workloads, more application environments. And as the cluster, continues to evolve, we'll certainly build out more of these. But Craig, thanks so much. Really appreciate it. Thanks for watching, and we will be back soon. Thanks.
All right. Thank you.